Hello, this is Mario from ODEON. In this video, we will help you get started quickly with ODEON by showing the setup of a model from start to finish. For that, we will use a quick workflow guide, which we will link as a PDF in the description. You can have this guide displayed on a second monitor while you work on your model. Although ODEON is often used for bigger projects, you can also do simple projects quickly. So, the PDF will also serve as a guide on how to quickly set up a model for a simple project and produce results in 10 to 20 minutes. If you would like to learn each stage of the workflow in more detail, we have a tutorial playlist with videos for each specific stage. The first step to simulating a room in ODEON is to draw a model of the room. You can import rooms in various formats, such as IFC, DXF, DWG, and others. For IFC, ODEON currently supports files from Revit and ArchiCAD. Alternatively, you can import directly from SketchUp into ODEON using the free SketchUp plugin available on our website. If you have no experience modeling, we recommend to use SketchUp, as it has a gentle learning curve. You can download the plugin by going to our website odeon.dk, Downloads, SU2 ODEON plugin for SketchUp. Just keep in mind that the plugin can only be installed on the desktop version of the app, so not on the web app. To install it, go to the Extension Manager, which you will find in the window menu in versions earlier than 2021, or the Extensions menu in version 2021 and later. Then click on Install Extension and choose the downloaded RBZ file. Again, we will start in Make a Simple Model in the PDF guide, and we will use SketchUp as suggested. So, in this section of the video, we will explain how to draw a simple room in SketchUp. If you are already familiar with SketchUp or use a different CAD software, feel free to skip to the next section, which you can do in the progress bar or by clicking here to open the chapters list. In the Draw Geometry section, the first step is to draw squares. To do that, we use the Shapes tool. Once you've started drawing the square and before you click, you can type the size, which will show at the bottom right corner of the screen. Confirm by pressing Enter. I will make an adjacent rectangle. To create a volume, we will pull up to a box with the Push-Pull tool. Just like with the rectangles, we can start pulling, type the height, and hit Enter. Make sure there are surfaces on all sides of the boxes. Otherwise, you may need to repeat lines with the Line tool. Then, remove surfaces between boxes if there are any. To check this, you right-click on a ceiling and select Hide. To remove a surface, simply select it and press the Delete key. Make sure to bring back hidden surfaces by going to Edit, Unhide, All. Otherwise, hidden surfaces will not be imported into ODEON. Finally, add additional room details such as large furniture, sound screens, etc. In this model, we will place an acoustical treatment on the top half of the wall. So we will split this side into two. On this side, we will draw 3 windows. For models with a lot of surfaces, we recommend to group surfaces by tags, which makes it easier to work with the model in ODEON. This model only has a few surfaces, so we can skip that step. We will now export the geometry to ODEON. To do that, we will first need to save the project. Keep in mind that the ODEON model will be created in the same folder where you saved the SketchUp model. And then press the SU2 ODEON button. The ODEON project will be created. You can choose to open it automatically, but for this example, we will open it manually. Now, the first step of setting up the model in ODEON is to import the geometry. In ODEON, go to File, Open Room, and navigate to the folder where you initially saved your SketchUp project. The ODEON project will be there as well. Next, we should place a sound source. In ODEON, you need at least one sound source in order to make calculations. We can go to the source receiver list by clicking on this icon. Keep in mind that all the icons in the toolbar can also be found in the toolbar menu. You can create a new point source by clicking this icon or with the Ctrl+P shortcut. It is important to remember that this menu between toolbar and options is context sensitive, meaning the name of the menu and the options within will depend on the currently active window. For example, since we are currently in the source receiver list, it shows options related to the source receiver list. This menu will show various hidden functions and hotkeys for each window in ODEON. So, try to make a habit of checking this menu often. In this case, the option to create a point source will also be available in this menu. In the point source editor window, you can type a description for the source. You can place the source directly on this blue grid with Ctrl left click. And you can change the orientation of the grid by rotating the model, which you can do by holding left click and moving the mouse. But if you want a more exact location, you can type in coordinates in the point source editor window. To save the source, we simply close the window. Then, we also close the source receiver list to save our source receiver setup as a whole. Now, we need to apply materials for all surfaces in the room. This is done in the material list, which you can open either by pressing this icon or going to Toolbar, Material List. The left side shows the surfaces in your model. By default, ODEON will display a list of layers. However, since we did not define layers or tags, it will only display a single default layer with all the surfaces. You can expand the list to show all individual surfaces by clicking this icon. When you select a surface in the list, you will see the corresponding surface highlighted in red in the 3D view. The right side shows the material library. Here, you can choose between different materials, which have different absorption coefficients. You can see the absorption coefficients at the bottom with a representative bar graph. we will look for the painted plaster surface, which is what we are going to use for most of the surfaces in the room. You can search for materials with this search box. Then we go to the surface list on the left side, select the desired surface, and assign the material. To do that, you can either press the Assign Material icon or use the Insert shortcut. In the Material column, you can see the material number assigned to the surface. Each time you assign a material, the cursor will jump to the next surface, so you can just click repeatedly. Most of the surfaces will have this material, so I will just go ahead and assign it to all surfaces. Just like in the source receiver list, I can also find the option in the context-sensitive menu for the material list. Just make sure that the active window is the bottom one. Now, we just need to assign the correct materials to the floor, windows, and acoustic treatment. For the floor, we will look for linoleum on concrete. This time, I will assign the material with the Insert key. And for windows, we have various glass materials. I will assign Glass Ordinary Window. You can select multiple surfaces with Ctrl-click or Shift-click, then assign them a material. For the wall portion where we will add acoustic treatment, we will assign Acoustic Plaster. So, now we have assigned materials to all surfaces in the room. There are other available options in the material list, such as assigning materials to full layers at a time or importing your own materials. These are explained in more detail in our tutorial on setting absorption and scattering. We will close the material list, and ODEON will ask to confirm the changes. The assigned materials have now been saved. The next thing on our list is to set accuracy. To do that, we open the room setup. Here, you should set an impulse response length and a number of late rays. For the impulse response length, you should set it to around the reverberation time you would expect in this room. Since this room has a lot of hard surfaces, we can expect a long reverberation time, so I will set it to 4 seconds. Be aware that if it's set too low, some results will not be shown. This is because the impulse response will not be long enough to fit the full reverberation tail. So, if later you are missing some results, you will need to come back, increase the impulse response length, and rerun the calculation. Here, you can change the number of late rays used in the calculations, which will determine both the calculation speed and accuracy. You can enter a low number for fast calculations or a high one for accurate calculations. For this particular room, 2000 late rays is more than enough. However, depending on your room, you may need more late rays in some cases. This parameter is extremely important to set correctly. So, we highly recommend to watch our video on calculation parameters where we explain it. You simply close the room setup to save the new settings. There's a lot of different calculation types you can make in ODEON. For a simple setup, you could look at the global estimate, which is the average reverberation time in the room. There is the point responses, where the acoustical parameters are calculated at specific locations defined with a receiver point. And you have the color grid, which allows you to visualize acoustic parameters across the room. Let's do the global estimate first. Keep in mind that this is available in editions Industrial, Auditorium, and Combined. The calculation will start automatically. If already calculated, you can press Recalculate. Once the calculation starts, wait a bit until the curves have flattened out. You can see that the curves are now flattening out into smooth lines. Once they are quite smooth, press Finish Calculations. Keep in mind that your entered number of late rays does not affect this calculation. Rather, it only applies to point responses and grid responses, which we will look at later. However, this calculation does take into account the entered impulse response length. We can change the tab to Estimated Reverberation Times. Here, we can see the global reverberation time for the room. If you want to add that to a report for a client, just press Ctrl+C to copy, and then Ctrl+V in an external software, such as an Office app or an image editor. This works with all graphical results across ODEON. Next is the point responses, which is the acoustical parameters at specific receiver positions. However, for that, we will first need to create a receiver point. To do that, we will go back to the source receiver list. Then, you can create a receiver here. Again, you can place it on the blue grid with Ctrl-left click. Remember that you can reorient the grid by rotating the model. Close the window to save the receiver. I will create a second receiver. To make the calculation, we go to the job list. Each job is a specific calculation setup. We can set up any job, so I will select Job 1 and call it Source 1. Then you activate sources, which you can do at the left side of the screen. Currently, we only have one source, so we will tick the checkbox. In this window, active sources will appear as a solid red dot. You could activate multiple sources if you had them, but for point responses, you should typically use only one. Multiple sources are only used in special cases, such as when simulating loudspeaker systems. You will have different types of point responses depending on your ODEON edition. The multi-point response is available in all editions, which calculates with your active sources at all receiver positions. The single point response is available in editions Auditorium and Combined. It calculates at a single receiver point, but it produces more types of unique results. For now, we will calculate a multi-point response, which we can enable by ticking the multi checkbox for that job. The multi checkbox at the top of the table should also be ticked. Then, to start the calculation, you go to Run Single Job. When the cell is green, it means the results are ready to be viewed. We can look at the results by selecting the job and clicking the View Multi-Point Response icon. In the Energy Parameters tab, you can see all the different acoustical parameters. For example, you will see EDT, T20, T30, Strength G, Clarity, etc. The first results shown are for Receiver 1. And you can scroll down for the results at Receiver 2. You can export the parameters by highlighting them and pressing Ctrl+C. If you press Ctrl+C without highlighting anything, it will simply copy everything. Then you paste the data with Ctrl+V. If pasting into a spreadsheet, the data will be arranged appropriately. The next tab is the energy parameter bars, where you have bar graphs of the different acoustic parameters. You can scroll through the parameters with the left and right arrows. As previously mentioned, you can also copy-paste graphical results. Finally, we will calculate a grid. This is useful if you want to display an acoustical parameter visually across the room. Keep in mind that this is available in editions Industrial, Auditorium, and Combined. First, we should define a grid, which we can do by clicking this icon. Again, you can also use the shortcut or access it from the toolbar menu. Here, you select on which surfaces you want to generate a grid. Down here, you can see the distance the grid will be from the floor. Right now, it's going to be 1.2 meters above the floor, which is fine in this case. By default, you will only see horizontal surfaces in the list. Remember that when you highlight surfaces, they are outlined in red. Here, we want the grid above the floor, so we need to select the floor surfaces. To select the highlighted surface, click on this icon. On the right side, you will see the surfaces currently selected to have a grid on them. And you can double-check the distance that they will be from the surface. You can preview the grid by clicking on this icon. This is not yet the results, it is just a preview of the receivers. For this small room, a distance of 2 meters between receivers is too large. So, I will set a distance of 1 meter instead. This looks more appropriate. I will close the window to save the grid. To calculate the grid, first we go back to the job list. I can enable a grid response in the same job I set up previously. We enable the grid calculation with this checkbox. To calculate the grid response, I go to Run Single Job just as before. To view the results of the selected grid response, go to View Grid Response. You can scroll through parameters with the left and right arrows. Since this is a small room, the reverberation parameters are very consistent throughout the room. I will just find the G parameter. And you can scroll through octave bands with the up and down arrows. As shown before, you can easily copy this image to a document. As you can see, we have made a full project in just a few minutes. To summarize, you first make a simple model. Here we used SketchUp, which we recommend. Then you set up the model in ODEON by importing the geometry, placing sound sources, choosing materials, and setting the accuracy. Then you choose which results you want, such as the global estimate, multi or single point responses, and the color grid. And finally, you copy your results and paste them into a report for your client. In this video, we completed a simple project, but of course, you can also use ODEON for very comprehensive models and prestigious projects like concert halls. As previously mentioned, you can learn each stage of the setup in more detail by watching our playlist of tutorials for getting started. However, if you just need to make a simple project, then you can come back to this video and use it as a walkthrough to set up simple projects quickly. We hope you have found this video useful. Good luck!